The last lesson was on 2 dimensions, and this one is on 3 dimensions. So if you go back to 2 dimensions, we basically had this situation where we had a y-axis and an x-axis, okay, and that was our 2 dimensions. You could go left and right, you could go up and down, but real life isn't just flat like this. This would just be flat. So it actually comes out at you. It's hard to show on this little tablet right here, but it comes out at you. So I found a little graphic that kind of represents this. And if you look at this, we'll cover up the X and Y. This has 3 dimensions in it. Look, this is like, see where this meets this right here? That would be like the x-axis. This up and down would be the y-axis. But then you got another one coming out this way, coming at you. And that would be the 3rd dimension. That would be a 3 dimension, right? Now, don't worry about that. That looks pretty scary, but we're not going to get into that very much. We are going to talk about certain figures. So far, all our figures have been flat. Okay, they've been... have we talked about triangles? No, but anything we've talked about so far really basically has just been flat. Now these are going to be have some depth to them. And for instance, this thing right here would be a 3-dimensional figure, because if you look at it, comes this way, this would be one axis, this would be the 2nd axis going in a different direction, this would be a 3rd axis right here. So there's our 3 dimensions. This thing right here, we're going to talk about this. This is not something we're going to harp on too much, but this thing right here is called a polyhedron. Some people say polyhedron, but I just say polyhedron. And this is a polyhedron. If you look at the definition, it says it's a solid, okay, with all flat surfaces that enclose a single region of space. All right, so basically it's a solid, which it is right here, and all the surfaces are flat. So let's talk about a couple of these surfaces. Let's talk about the flat surface itself. There's a bunch of them on here, but this flat surface of the polyhedron would be called the face of the polyhedron. Now these lines, see where the faces meet, or those planes actually meet each other? They meet each other at this line right here. Well, that would be called an edge. I think we've talked about that before, but we'll just reiterate. And then now, watch, where the 2 edges come together, let me draw another edge, and it comes together right there. Where they come together at that point, that's called the vertex. And just write vertex up here, just so you kind of get some vocabulary down. So the flat part is the face. Now there's a bunch of faces. There's one on the top, there's here, there's on the bottom, there's back behind it. If I was able to twirl it around, you could see the different faces on it. So this thing is called a polyhedron. Remember, it has to be flat. Can't have any curves or anything. So the surface has to be flat. That's a polyhedron. So what we're going to do is we are going to show you several polyhedrons and some things that actually are not polyhedrons. I've got them all on one graph. Let me scooch this down a little bit. There we go. All right, now I've got some things that are polyhedrons and things that are not polyhedrons. Remember, a polyhedron has to be all flat surfaces. So let's see what our polyhedrons are. Let's just put a P for polyhedron and an NP for not polyhedron. How about that? So what about this thing right here? Does it have all flat surfaces? Absolutely. So this would be a polyhedron. What about this? Do we have all flat surfaces? No, nowhere on here is it flat. It's all curved. So this is not a polyhedron. What about this? That looks kind of straight, but look at the surfaces though. That's not flat at all. It's curved all around. But you say, well, what about the bottom? It's flat on the bottom. Yep, but all the surfaces have to be flat. So we would also consider that not a polyhedron. What about this one? It's flat on this end and it's flat on this end, but look around the sides of it. This is curved, so this is not a polyhedron. What about this? Oh yeah, everything's flat here. Okay, even though it comes to a point, everything's still flat. There's no curves like this, even on the bottom and all the sides. So yeah, that's a polyhedron. What about this thing right here? Yep, we already talked about that up top. That's also a polyhedron. Now let's take a look at the words. All right, we said which is a polyhedron, which is not. Let's get rid of all of that. There we go. Now let's take a look at what these are. This is called a rectangular prism. So when it's a prism, first of all, it's rectangular because it's sitting on a rectangle. We would call that the base of this. Okay, whatever it's sitting on, we would call that the base. And the base is a rectangle. And look at the sides. The sides go just straight up. They don't slant or anything like that. They just go perfectly nice and straight up, and it's flat on the top and flat on the bottom. We would call that a prism. Now there's different shapes. I don't have them all on here, but you can have all kinds of, you can have a triangular prism, okay? As long as you have a triangle and all the sides go straight up, not to a point like this, but if all the sides go straight up, you would have a prism. Are there any other prisms here? Yeah, you can look at this thing right here. This is a prism. It's sitting on the base, and look at all the sides. They go completely straight up. This is kind of a prism. If I took this thing and I put it on its side, all right, and I said that it was sitting on this or it's sitting on this right here, all the sides would go straight up. But it's not a polyhedron because it's curved. We would call that something else. We would call that a cylinder, right? It's kind of like a prism because it's flat on the bottom, flat on the top. So prisms are always flat on the bottom, flat on the top, just like we have right here. Now that's pointy at the top and that's pointy at the top, so they're not prisms at all. This is a sphere. It doesn't have any points or edges or sides or anything. That's just, basically it's a ball, all right? That's a sphere. Kind of sounds weird, but sphere, you got to see the S and the PH. What about this thing? This has a flat surface. It's got a circular, okay? It's a circular base or bottom. And look at the sides. They don't just go straight up. If they went straight up, it'd be a cylinder. They come up to a point. If they come up to a point, okay, we call that thing a cone. So by the way, let's write this on here. Remember we talked about this though. What it's sitting on is called the base, and the top is the base as well. So it's got two bases, one on the bottom and one on the top. They would be the bases. A sphere doesn't have a base at all. What about the cone? Yep, this would be right here, right? If I put kind of the dotted line around like this, you can kind of like see through it. That circle that it's sitting on would be considered the base, all right? Now, where it comes to a point, see this cone and this pyramid, they both come to a point. And we call that point right there vertex. Okay, we'll call a lot of things the vertex. Whenever it comes to a point like that, it's usually called the vertex. So this would be a vertex as well, and the bottom would be a base. Now, watch, if I usually use like dotted lines to kind of, that's terrible dotted lines, sorry about that, little curved. But what that does, it represents the back end of it and this back end of it, and this thing actually probably should go like this. Wow, I killed that thing. Let's get rid of all that mess. But you get the idea, I think. You have the base on a pyramid. Now, a pyramid could have all different shapes of a base. It could be a 5-sided, 4-sided, 3-sided base. It could be more, 6, 7, 8, 9, 10, the base. But look what it does. All the sides do what? They all come to a point. This is a circle base, and it comes to a point. This is all kinds of different polygon shapes. Polygonal, if you want to call it that, shapes. And it comes to a point. If it comes to a point, if it's circular, it's a cone. If it's like rectangular, if it's straight sides on the bottom, it would be a pyramid. Sometimes I even mix up the words prism and pyramid. They both start with P. That's easy to do. But this would be a rectangular prism. Why? Because the bottom is a rectangle. What about this? Now, they call it a cube, but you could call it something else. Look at the bottom. The bottom kind of looks like a square, doesn't it? Okay. Now, they don't usually call it a square prism. You don't really hear that very much. At all. I don't think I've ever heard that. So they give it a nice, easy word, and they just call it a cube. And that's what it means. It means the bottom is a square. So it has a base, two bases. Okay, it's got a base down here, and it's got a base up here. Right? So a cube is basically a prism. It's just a square bottom, a square base, and this is a rectangular base. You could have all kinds of shapes. You could have a pentagon, all right, 5-sided, 6-sided, 7 figures, or 7 sides. You could go on and on and on if you wanted to, as long as the sides do what? They go straight up, and the bottom and the top are the same, then we have a prism. Look at this thing right here. This is a cylinder. It has a base. Now, you say, yeah, but it's not sitting on it. You're right, it's not. It's kind of on its side, isn't it? This right here would be the base of the cylinder. Now, you can't see it, but you know it's over here on the other side, right? And if I was, again, to put a dotted line, that kind of shows that over here. So this would be a base as well, all right? And let's see. That's all they say about that. Oh, the sphere has a center point. It would be right here, and it's the same distance to anywhere on that sphere, all right? We would call that the radius of the sphere if we wanted to, but it's got no faces, no edges, no vertices, none of that stuff, all right? Hope that makes a little bit of sense. This thing right here was taken right from the book, and it gives different names. I kind of was describing it for you, but here's kind of a picture. This is a triangular prism. Remember, prisms just go straight up and down. Now, it looks like it's not sitting on you wouldn't call that the base right here. All right, let's blow that up a little bit, or enlarge it just a tad. There we go. Look at this thing right here. That right there is not the base. This would be the base. Why? Because it's the same on the bottom and the top. That makes it a prism, okay? Because there is no top of this bottom right here. There's like just this side and this side right here. But you've got the, what do you want to call it, the front end, the back end. But if I took this and I tilted it up, then it would be sitting on this triangle. That's why it's a triangular base. Look at this thing. It's a rectangular prism. We already talked about that. This is a pentagonal prism. What's that crazy word? From Pentagon. It's sitting on a five-sided figure. Look at the sides. They go straight up. They go straight up. And the top and the bottom are exactly the same. That makes that thing a prism. All right, let's move this thing around. We'll keep it enlarged so we can see it a little bit better. That's good right there. All right, let's look at this. This is a triangle pyramid. Notice the difference between a prism and a pyramid. A pyramid comes to a point. A prism, the sides just go straight up and down. So let's take a look at the pyramid. The pyramid, it's got a bottom, right? The bottom of it is a triangle. If I was to kind of maybe color it in a little bit, right? See, that would be what it's sitting on. That would be its base. And what's it doing? Look, all the sides are going up to a point. There's the common point that they all hit. See that? That's coming, that edge comes up to here, and this edge comes up to here. They hit at that common point. That's the vertex. These are the edges, and this thing that I colored in would be the base. Now, that base is a triangle. Look, three sides. This right here, the base of this is a rectangle because there's four sides, and it all comes up to a point. Look at the base here, five sides, so it's a pentagonal pyramid. All comes up to a point. So that's the difference between prism and pyramid. You have something that looks very familiar, or not familiar, but it looks very similar to page 68. It's the top of 68. The picture on 68 is a little flatter, but I found this on the internet, so I like this box right here. But if you take a look at it, all they do is ask you to name all the different things. So name all the bases. So what were the bases? Well, it's sitting on this part right here. So it's a rectangle, so you would just name it rectangle. You can name it all kinds of things. E, H, G, F. All right, you kind of name it. You start with one point, and you go in a certain order. Doesn't matter. You can go this way or you can go this way. You just don't go diagonally. So I could call it E, H, G, F. I'm not going to write all these down. You can if you want, just for the time's sake. So that would be one base. What would be the other base? Well, the top. Remember, the top and the bottom on a prism are the same thing. So I could also call the base A, B, C, D. All right, so the top and the bottom. Now, I don't have to start with A. I could have called it C. I could go C, D, A, B, or I could go backwards and call it C, B, A, D. So there's all kinds of ways that you could call this stuff. All right, let's talk about the faces. Now, that would be the bases, right? That would be a base right here, A, B, C, D, and this would be a base down here, E, H, G, F. Now, what about the faces? This thing right here, let's just kind of highlight it so you see it right there. Does that make sense? It's this left side to it. That would be a face. Now, I'm not going to read all these off to you, but you can get the idea. If I wanted to name this face that I've kind of colored in here, what would you name it? You'd name it A, D, F, E. Right? And any combination, it doesn't matter. It doesn't matter where you start. You just have to go around the horn. Okay, don't go across. Don't go from F to A. But I could go A, E, F, D. I could have started at F and gone F, D, A, E. I could have started at E. All right, you get the idea. There's all kinds of different ways that you can name it, but it's the same face. So this would be a face. This right here, D, C, G, F would be a face. This side over here, this right side where you can kind of see through it, B, C, G, H. Then you got the back of it, A, B, H, E. So those would be the faces. All right, so all those would be the faces of that thing. Now, what about the edges? Now, the edges are all the straight lines. Look, AB, it's a line segment, so we call it line segment AB. That would be an edge. So right here would be an edge. And there's a bunch of them. You can name them if you want. BC, CG, FG, BH, HG. There's a whole bunch. All right? And what about the vertices? That's really easy. It's just where the edges come to a point. So point A, that would be a vertex. Point D would be a vertex. B, C, G, H, F, E. They all would be vertices. Okay, remember vertices is plural for vertex. All right, so that's just to give you an idea of what you would call this. Now, again, what's this thing called? It's a polyhedron, but it's also a rectangular prism, right? Because the bottom is a rectangle, the sides go straight up. It's a rectangular prism. You can call it a box, I guess, if you wanted to, but that's not what we're going to call it. You want to get real technical, it's a rectangular prism. Let's look at another shape. All right, let's take a look at this and just kind of talk about what it is. This is a cylinder, right? You've got two bases. You got one here and you've got one here. Remember we did the dotted line earlier? So you have two bases, but you have a curved surface right here. So it's not a polyhedron, but it does have a name and it's called a cylinder. And on this cylinder, we have bases. So this would be a base right here. And then again, if we do that dotted line thing, you can kind of see where that other base is. This would be a base. Now, if we took this, tell you what, let's get rid of all that, okay? And let's take this and just kind of turn it up on its side. Let's see if I can do this. Rotate it. Let's go 90 degrees. And there we go. All right, so if I put this on its end, okay, it looks like it's kind of crooked, but you get the idea. All right, if I put this on its end, we could call this the height, right? Because if it's sitting down, now it looks a little tilted, okay? The angle's probably bad. You know what I could do? Sorry. Sometimes I have to have it just right, and I know what you're thinking. You're thinking you're a little picky, aren't you, Hamrick? Yep, I am. Let's go 180, and let's do that. That looks a little bit better, I guess. I don't know, does it? Well, anyway, what am I trying to do? I'm trying to show you that the base is right here, just like it was when it was sitting on its side. This is still the base. Can't hardly see that, can you? And then this is the base as well. And what about right here? That distance right there, and we're not going to get into it in this lesson, but that distance right here would be the height of the cylinder. We have another chapter where we're going to get into this really heavy. This is just, it's just barely getting into it. That right there would be the height. And we actually we will need to know that a little bit later on in the lesson, in just a minute actually. So I guess we will need to know that. So that is the height of the cylinder. Let's see. Let's do another one. Okay, here's a different shape. Look at the bottom though. The bottom still looks like a rectangle, doesn't it? It's a four-sided figure, okay? But look at the sides. They don't just go straight up. It's not a prism. What is it? If it comes to a point right here, okay, it is a pyramid. So that is a pyramid. It's a rectangular pyramid. Why rectangular? Because the base, the bottom of it, is a rectangle. So let's name some of these. What is the base? Well, the base would be this four-sided figure, this rectangle. So I would say the base is the rectangle ABCD. I think they do this in the book, and they put a little symbol there. Actually, the one in the book is a triangular prism, or a pyramid, but I couldn't find one on the internet, so we're going to use this one. This looks kind of nice. All right, so so this would be the base right there, that ABCD. Now, what about these sides right here? What do we call that? We call that the face. And you've got four sides to the base, you got four faces. So I would call this triangle AED, because look at the face. It's a triangle, isn't it? The base isn't, but the face is. Face, right? AED. And then you've got EDC. You've got this one back here, EBC, and you've got this one back here, EAB. So they would be the faces. What about the edges? That's easy. The edges are just the line segments. AE is an edge. ED, EB, BC, DC. Any of those straight lines are edges. What about the vertices? That's super easy. It's just where the edges come together at a point. So point A is a vertex, D is a vertex, C, B, and E are all vertices. All right, pretty simple. I think you got the hang of it now. This chart right here is on page 69, and you can look it over yourself. I'm not going to go into great detail. To tell you the truth, I probably will not have you memorize this right now. We will have a chapter later on in the book. It's like way towards the end of the book that I will have you memorize these things. In fact, I'm not even going to ask you to memorize these exact formulas. There's another way that I have to teach to get you to remember how to find what they're asking for here. But don't worry about that right now. Just on this chapter, all I want you to be able to do is use this chart right here, okay? So I'll probably even give it to you, I believe, on the last last year's test, I actually gave them this chart. All you got to do is know how to use it. So let's talk about what this stuff means. Look, it's pretty self-explanatory. They tell you all this stuff down here. But what are we doing here? We're finding the surface area. Remember, the area is how many squares you can fit on that flat piece or on that flat surface. But on this one, it's not flat. It's three-dimensional. So we have a lot of different areas. We got the top. We got the bottom, we got the front, we got the back, we got the left side, we got the right side. So how are you going to find the area of all that? Well, they give you a nice little formula right here. The T stands it stands for the total surface area. So when I would teach this, I would put SA for surface area. T, I don't know if that's the greatest thing to put for that, but just remember T is the total surface area. That means you're finding the area of the top, the bottom, the left, the right, the front, and the back. All right, but you can do that all with this one formula. Let's take a look to see what this stuff means. P times H. Well, what is P? P stands for the perimeter of the base. The perimeter is the distance around the base, and that's why they put this arrow right here. Do you see it? Remember, the top and the bottom are the exact same thing, so you could look at either the bottom or the top. If I knew these distances, and they'll tell you a bunch of distances around this, I would just add up all the distances. Okay, and that's the perimeter of the base. You take that number and multiply it by the height. Which one's the height? Well, they tell you again right here. The height is this one. All right, so you're going to add up the four sides on the top. That's the perimeter. You're going to multiply it by the height, and then you're going to add the two bases. All right, so now you're going to find that not just add the two bases, but the area of the bases. So you would find the area of the top, and then you just basically multiply by 2. That's why you got the 2b right here. All right, so P is the distance around, so the perimeter of the top or the bottom. H is the height, how tall it is. 2b, B represents the area. Now, area of a rectangle is length times width. We've talked about that earlier. So we would go length times width. You multiply it by 2 because there's a top and a bottom, and now you've got the total surface area. All right, to find the volume, look, volume's actually a little easier, isn't it? Let's get rid of all these red marks. There we go, that's good enough. I'll keep that up here. Volume is how many cubes can you fit inside of this thing. That's what volume is on all of these. It's how many cubes can you fit inside of that three-dimensional solid. So to find the volume of this, you find B. What does B represent? Well, it's the area of the base. B is the area. So how do you find the area of the base? It's a rectangle. It's length times width. If it was a triangle, it would be 1/2 the base times the height. Whatever the figure is, if it was a circle, it's pi r squared. Look at this, see? Pi r squared right there. Because the cylinder is basically a prism with a circular base. All right, so how do you find the bottom, or the bottom? How do you find the volume? You find the area of the base, and you multiply it by the height. That's all it is. So it's this times this times this. You multiply those three together, and you've got the volume of this thing. All right, that should make a little sense here. Let's take a look at this. This is a little bit different. The total surface area. Remember, surface area is just the area, or the area of all the sides and the bottom. Okay, we're not talking about the inside at all, just talking about the sides and the bottom. So the total surface area is 1/2 P. P is the perimeter of the base. This is the base right here. So I would find the perimeter of this base, okay, multiply by 1/2, or take half of it, right, and multiply by L. Now, L's a little different. L is called the slant height. The slant height, and it tells you, where does it tell you? Yep, right there. L is the slant height. The slant height is, like if you're going to sit on top of this pyramid, on top of that point, wouldn't be very comfortable, but if you were to slide straight down, okay, down the side, not down the middle, okay, if you're going down the side of this pyramid, that right there is the slant height. So, and they'll probably tell you that, or you can figure it out, all right? So it's 1/2 the perimeter of the base, that's what the P is, right? Perimeter of the base times the slant height plus B. What's B? It's the area of the base. I told you it'd be hard to memorize all these, and I have a much, much better way to learn this stuff, and we'll do that when we get to that other chapter towards the end of the book. But right now, I just want you to be able to use this chart, all right? So the volume, did we cover that? Yeah, 1/2 the perimeter of the base times the slant height plus the area of the base. In this case, the base is a rectangle. That's easy. It's just length times width. What about the volume? If I want, how many cubes can I fit inside of this thing? Well, it's 1/3 the area of the base times the height. Now, where is the height? The height, let's do this in a different color. What will stand out? We got already blue there. Let's go yellow. So the height goes from here straight down to the middle of the base. Now that actually goes through it. So if I was to throw a rope down, there's a little hole at the top of this pyramid, okay? We're Indiana Jones. And there's a rope that goes straight down. If I go straight down, okay, to the middle of that base right there, that would be the height. That's the H right there. That's different from the slant height. The slant height is going down the side of the pyramid, and the height, the actual height, is going straight through the middle of it, okay, all the way down to the center of it. That's that height right there. And again, they'll probably tell you all that stuff. All you got to do is just plug them in a formula for right now. They'll make it real easy at first. All right, let's talk about this real quick. Total surface area. Again, we're finding the area of everything around it, the top, the bottom, and all the sides. Here it is, 2 pi r. What's r? It's the radius, okay, from there to there. It's the radius times the height. We talked about that a little earlier. That's the height, okay, plus 2 pi r squared. Again, don't have to know where it comes from, just know how to use it. How do you find the volume? Pi r squared times the height. You already know what the radius is. You already know what the height is. Plug them in, you're good to go. All right, here we go. We've got a height and a slant height, kind of like we did over here, but this time it's a cone. Total surface area. Pi times the radius, which is this one right here, times L, which is the slant height. See how it's going down the side of it, not straight down the middle? It's going down the slide. That's the slant height, down the side, sliding down the side, okay? Plus pi r squared, and pi r squared is, there's the r right there for pi r squared. All right, how do you find the volume? 1/3 pi r squared h. So as long as you know what these things are, h again is this distance from the center down to this vertex. It's a little raggedy, but there you go. Okay, that would be the regular height. The L right there, that's the slant height. Make sure you know the difference between the two. Again, I'll give you the chart. You can just use the chart. One more, the sphere. The total surface area is just 4 pi r squared. They'll probably give you the radius. All right, it's just from here to here, and you just plug it in. That's all you got to do. What about the volume? These are weird equations, but again, I got a better way to show you how to do this, and you're going to have to wait till the end of the year, though, to learn this. So it's 4/3 pi r cubed. Again, it's not that big of a deal. As long as you know what the radius is of a sphere, it's really simple to find these, okay? So I will give you this. I'm not going to make you memorize it. Don't worry about that. Okay, we got 2 examples to do. Here's the first one. We'll try to go quickly. They ask you to find the surface area of this, and they ask you to find the volume of this thing. Well, if you look at that chart we just went over, the surface area, now they use T. I always use SA. I guess we'll go back to the T. Hopefully that doesn't bother you. Let's scribble that up, put T. What's the total surface area? Well, it's 1/2 times the perimeter times the slant height plus B, which is the area of the base. So we're going to have to figure some things out. They give us everything we need to know, but we're still going to have to figure stuff out to find the total surface area. So it's 1/2 times the perimeter times the slant height plus the area of the base. So let's just let's take a look, and it says it's a square pyramid, okay? It's a square pyramid. So that really helps us. How does that help us? Helps us because if I know this is 6, that's 6 as well, right? Because it's a square, because all 4 of these sides are equal to each other. That's 6 and that's 6 from there to there. All right, so that helps finding the perimeter. That's pretty easy. So if all 4 sides are 6, then what's the perimeter of it? 6, 6, 6, and 6. 6 4s are 24, so it's just 24. Times the slant height. You can look. Now, which one of these goes down the side of it? This one right here. So that's the slant height. It's 5, so I just stick a 5 right here. Plus B, the area of the base. Now, you got to think area. This is a square, so how do you find the area of a square or area of a rectangle? It's a length times a width. 6 times 6. What's 6 times 6? It's 36. So now you plug all that stuff in. Let's do this in our head. 1/2 of 24 is 12 times 5 is 60 plus 36 is 96. All right, so the total surface area is 96. Now this is area, so it's centimeters squared, and that's how you find the total surface area. Now let's do the volume. Volume's actually a little easier because we actually found something over here that we're going to use. The volume is, let's do this in a color. Let's go right here. So the volume is 1/3. I'm just taking this from the chart. It's 1/3 times the area of the base times the height. So let's plug some stuff in. All right, so what's the area of the base? We already figured it out. We said the area of the base was 36 up here, so we're just going to put that 36 times the height. Which height? That's just the regular height. The h is the regular height. That means it's at the top of this pyramid straight down to the middle, and they tell you that that's 4, so we're going to put a 4 right here. All right, so now we can find the volume of this. So 1/3 of 36, that's easy. That's just 12. 12 times 4 is 48. Its volume is always cubed. It's how many cubes can you fit inside of there. So volume is cubed, area is squared, and you're done. All right, this is the last one, and we'll stop after this, okay? They ask you to find the same exact thing, the total surface area and the volume. Okay, they ask for both of these things. I think I got this a little bit too big. Let me pause. Let's try this again. Sorry, I just didn't have my stuff right. Let's find the total surface area. Well, we need to know how to find that. So if you look in your chart, you don't have to memorize it. It's 2 pi RH plus 2 pi r squared. And so let's put some stuff in here. We got 2. I'll just leave pi as pi. You could put 3.14 if you wanted to. R, what's the R? The radius. Now look, that's 8 feet, but that's not the radius. That's the diameter of the circle. You probably learned that before. So where's the radius? It's from here to here, so it'd be half of that. So the radius is actually 4 feet. Okay, make sure you do that correctly. So the radius is 4 times the height. What's the height? It's the straight up and down distance. Okay, now look at what this is in. This is in inches. So let's do this. Let's change the, I just realized that it was in inches. Let's change that 4. Instead of saying 4 feet, let's put it in inches. I think it'll be a lot easier to put this in inches. So what is 4 feet? Where am I going to do this? What is 4 feet in inches? What do we do with that? Okay, we have to multiply it by 12. So 4 feet would be 48 inches. So that's what I'm going to do. So I'm going to say 48 inches. Now that was a little tricky. Okay, so I almost missed it myself. So you got to put the 48 there. So let's put 48 for the radius. And what's the height? Now you can put the 20. Now you could have changed it to feet, but I think it's better to change it to inches in this case. Plus 2 pi r squared. Again, the r is 48, and then you square it. Now, this takes a little bit of doing on the calculator. Since I'm running past my 30-minute mark, I'll just tell you what it is. Well, I just noticed something. I just was figuring this was a whole cylinder, but if you're trying to find the surface area of the pool itself, think of the top of this. That doesn't really have any surface to it, does it? It's just empty. So really, you just have the sides and you have the one bottom. So guess what that 2 does right here? That 2 is for the top and the bottom, so I don't need that 2 there, so I won't have to worry about that. Now I noticed also in the book that instead of changing it to inches, they worked with this in feet. So instead of showing you how to convert it to inches, which might be a little bit more of a pain, I'll tell you what, let's get rid of all this, and we'll get rid of that. Okay, so let's stay with the feet. So instead of 48 inches, let's just go 4 feet. Now what they do here though, this might bother you a little bit, but they went 20 inches. Now here's how I convert it, and they converted it to feet. So there's 1 feet and there's 12 inches, and it's 20 divided by 12. And let's see, 4 goes into that 5 times, and 4 goes into that 3 times. And that's actually 1 2/3 feet. And that's what they use right there. It's unfortunate. I wouldn't do it that way, but the book does, so that's how I'll do it to stay consistent with the book. All right. So that means the height is 1 2/3. So the radius, we'll go back to that 4 feet, and then we're going to go 1 2/3, or to tell you the truth, I'm just going to keep it 5/3. I would rather deal with the improper. And then what was the radius over here again? It was 5/3. All right. Now look, I'm going to let you just put that in your calculator and see what you get. And you should get somewhere around 92.2 feet. And that's squared because it's the total surface area. All right, you may need to take some time and work on that to see if you get that, but you've got the time. Give it a shot and see if you can get that right now. All right, let's go to volume. Now, if you read the problem, which I didn't write down here, but it says on part B, it says the volume. What is the volume of water needed to fill the pool to a depth of 16 inches? Now, the pool is 20 inches high, but normally you would not fill a pool all the way to the very top because it would all come out anyway. So he only filled it to 16 inches. So really, from here to the bottom, okay, that's what we're trying to find the volume of, and that's actually 16 inches. Okay, so you just got to read the problem right there. So they ask you to find the volume. How much water is in this pool? How many cubic feet are in the pool is what they're asking for. So you need an equation, a formula. It's pi r squared h. It's that simple. Okay, so it's pi 3.14 times r. Remember what we said? R was the radius, and that was 4 feet. So we'll put a 4 in here, but then you got to square it, times the height. Now, what's the height? It's 16 inches. Let's convert 16 inches, okay, into feet, because that's what they're doing in this problem. And so inches is going to go on the bottom, feet's on the top, and 1 foot 12. Let's see, 4 goes into that, what, 4 times? 4 goes into that 3 times, so it's 4/3 or 1 1/3. I think the math is easier if you just keep it 4/3, so I'm going to write it as 4/3. Now, you plug all that into your calculator, and hopefully if the book is right, it's 67, and they put 0.0 because they round it to the 10th place, and that's cubic feet, or feet cubed. Sorry went a little long on this, but it was chock full of information. All right, good luck when you do your homework the next day. We'll see you then. Bye.